LogiEdge assignment, LogiBridge assignment. First, let me show you like the environment setup. Right, so like this is where is our assignment solution is present. Let me quickly show you that. So here under solution we have worked out the complete solution, and we have put different deliverables, and the same thing is committed into our GitHub repository, and we have provided the GitHub repository link as well. Right now let's set up the environment. So I'll show you like the Docker information. Right, so the Docker is up and running here. Right, so the Docker is up and running. Let me show you the Docker information. So this is the Docker information. Everything seems to be good here. We have the server, containers, 2 stock 2 images, 4 server version which is compatible with our system, right? And then let me check if everything related to Python pip is good or not before proceeding. So there is no broken requirements found, so we should be good. So let's move ahead and set up all the different components that we need. So this is like just an instruction set for me to execute this demo. So let me show you like all the components that I have set up. So the local broker is running on terminal 1 here, and then this is the terminal 1, and let me get it started. So let me start the local broker. So this will, so if you see the broker has started, local broker has started. Now let's go ahead and start the local MQTT subscriber as well. Right, so here is the terminal 2 where the local MQTT subscriber I will start up. So the local MQTT subscriber has started, and we can see like here like received subscription has come back in terminal 1, like the local broker. Right, so that shows the subscription. Now let me start a clean inference run. Right, like let me check once. So the inference service we can run, we can start using this command. Let me start that. So in the terminal 3 I have set up the inference service. So here is that. So there won't be any output, but yeah, the inference service has started up here. Like we can see that infer truck 001 has come into the local broker that we have set up, which means like the inference service is good, up and running. Now let me go ahead and start the PSI monitor on terminal 4. Let me go to terminal 4. Here the PSI monitor has also started, and we can see that it has started the inference here. So we should be good, like the PSI monitor is started. Now let me start the truck simulator on terminal 5. Let me go ahead and start that on terminal 5. So the simulator has started. The moment the simulator has started, the subscriber started receiving all the anomalies that the simulator truck simulator works out. It is sending. So let's leave this running for at least like 18 minutes. We will pause the recording here so that like we can see that the PSI should fall back less than 0.1 with this current setup that we have running. it should be coming back to less than 0.10 because that's a stable run, because there is no truck simulator anomalies that are being sent. Let me so it's in the 5, so there is no anomaly, right? So that's why the PSI should come back to less than 0.10. So I will leave this running like for 18 minutes, because every 10 seconds it keeps sending the details, so it will take some time for this to come below 0.10, right? So let me leave this running like this, and I will resume it back again. Okay, so let's resume back our demo. So you see, like after waiting for some time, like the PSI has dropped to less than 0.10. So PSI is rolling and it's printing like 0.032, that is less than 0.10. Now let me go ahead and start rest of the components of this assignment. So let me start the operations broker on terminal 6. Let me open that. So terminal 6, like let's start the operations broker. So the operations broker has started on terminal 6, and on terminal 7 let me start the operations alert subscriber. So on so there won't be any output, so the operations alert subscriber has started. And let me finally start the uplink worker on terminal 8. So let me go to terminal 8. So the uplink worker has started on terminal 8. We can see that client uplink truck 001 has come up, right? So now so that completes our environment setup. All the components are up and running now. So let me move ahead with let's review our system architecture diagram for this assignment. Let me go there. So our assignment solution is present here. Let me go to the system architecture diagram. So this is the our system architecture for LogiEdge offline for system architecture. Refrigerated truck, safety path like less than or equal to 90 seconds, and like these are all the components: sensors, local MQTT broker, inference pipeline, durable local alert log, device management, and operation center, like having cellular MQTT, SaaS, TLS gateway, and the backend services that it has. So here, like durable local alert logs stores and forwards the data to cellular MQTT, TLS gateway, that the operation center. This is an offline first edge AI platform, like for the 85 refrigerated trucks, local with local sensing and inference alerting and durable storage continue, like even during cellular outage it continues. Like our gates are like 88% accuracy, we will see the results, and like above 95% critical recall, and a 90-second response SLA is met. So this was the system architecture diagram. Now let me show you the 4 sensor modes and MQTT flow. Let me show you that. So here, like I will use truck sensor so that like truck 01 PSI remains unaffected. Let me show you all of them. Like I'll just run for 8 seconds, and then I'll stop each of the one. So here let me go to the terminal 9 where we can run these commands. So there is this is the none mode, right? So let me this was already like the default none inferencing that was already running here, right? And let me run the other ones. So temperature drift, let me run that. Yeah, this can run for some 8 seconds. Like if you see, like truck hyphen sensor has already started running, right? Like that was for the anomaly none mode. Let me now kill this one and start the next one. So temperature drift mode. Now this temperature drift mode has started. We can see sensor temperature, truck sensor temperature, right? And like here also we can see like the inference is also running for truck 01 and then truck sensor for the temperature, right? Like let me run the next two of them as well and show you. So let me kill this. Now the anomaly vibration mode I'll run. So it has started running. So if you see truck sensor vibration also has started here, vibration RMS. Now let me run the last one, like the combined mode. Let me stop this again and run the combined mode. So the combined mode has started, and now we can see like all of them reporting here for trucks and truck sensor, right? Are coming for all the combined ones. Okay, now let me move ahead to so like we support like these none, temperature, drift, vibration and combined modes. So temperature runs at 1 hertz, vibration RMS at 0.5 hertz, and door generate timestamped events. QoS1 protects safety records. QoS0 suits replaceable vibration samples. We form 6 fused features from 30-second windows every 10 seconds and publish to the required inference topic, right? So now let me quickly show you the training and normalization data that we have. Let me go to the yeah, let's stop this thing and let me show you that. Let me go here. So let me show you the metrics, training metrics that we have. So these are all the training metrics that we have. So like the accuracy is 1.0, accuracy shifted 3 sigma, 1.0 critical recall, confusion matrix values. Classification report we have for all the labels 0, 1, 2. Right, and then the accuracy and these are like the train indices, and we also have the validation indices. So that is the training metrics. Like let me show you the normalization experiment from the report that we have. Let me go there quickly. So let me check that. Yeah, here. So like the normalization report, let me show you that. Yeah, so this is a mandatory normalization sensitive experiment. Like this is the inference condition, statistics, source, accuracy and the change. So if you see like correct stats have like 10-minute clear normal, statistics sources like 10-minute clean normal, and like we have an accuracy of 100% and there is no change observed for that. And the mean shifted plus 3 sigma, like we have statistic sources like intentional corruption that we do. Then we see like accuracy as 100% and there is a 0.00 point change. So that result does not like validate wrong normalization, but like the synthetic classes are so separated that labels remain like unchanged. It instead motivates like the distribution and confidence checks on harder field data. right? So this is like the normalization experiment. So basically we generated like 294 windows and trained 3216 ReLU MLP, right, ReLU network with a three class softmax. That's why you saw like the results were like 0 1 2 labels. We use three class softmax and stratified like 80-20 split, and like the normalization uses only a separate 10-minute clean run. So M2 achieves like the 100% validation accuracy. The required plus 3 sigma test also measure like 100% on this strongly separated synthetic data set that we have. So that was about the results on a high level. We'll come back to this Pareto chat again. Now next moving to like Docker model. Let's check the Docker model layer cache, right? So let me show you the inference Docker file that we have. Um, so this is the Docker file that we have, and like here copy model TF light is present, right? If you see on line number 11. Now let me show you that so we see like here copy model tf light dot we have copied the model. Now moving ahead to so here we use like Python 3.11 slim and accept model path. All dependency layers like precede the model copy, changing only like M2 to M3, reuse the dependency and the service code layers and rebuild only the model trail. Right. So let me move ahead with showing you the how like live outage and PSI injection. Let's proceed with that. So let's first check the terminal 4 before we move it should be showing like less than 0.10, right? Now let me go there. So it's showing as less than 0.10, which is what is required. So that now let's induce the live outage. So in terminal 5 let me show you this. So let me first stop the terminal 6, which is running the operations broker. I have stopped that. In terminal 5, let me do a stop like anomaly mode, and then we'll start the anomaly mode in terminal 5. So we started in terminal 5 like the anomaly mode, and the local inference like will continue in terminal 1, right? It's continuing, and also we can see in terminal 2 also it is still going ahead, right? Like the inference is also going ahead. Now next let me move ahead with since we stopped the terminal 5, right, which to combined mode now, and also we stopped the broker. Let me show you the unsynced alerts count. So it is greater than 3, right, because the broker has been stopped. Right. So now let me show you that the PSI value in terminal 4 like will be greater than 0.25 in some time. Yeah, so here let me just go ahead and check this thing. So it should go to more than 0.25 in 5 minutes. So like our clean PSI is below 0.1. We now like stop only the remote broker and inject a combined anomaly. So local inference continues like without cellular access. We saw alerts are like also stored before transmission. That's what like the count has increased. So the unsynced count was above 0. The rolling monitor now like reports should report yeah, so it has reported more than 0.25. So this is like prediction output drift, and like this triggers the investigation, right? Like yeah, so let's move ahead with the next task. So let's restart the terminal 6, right? Like let me go ahead and restart the terminal 6. So I have restarted the terminal 6 here, right? Now let's see like the replayed messages from the terminal 7. Mm, so if you see like the messages are replayed which were unsynced previously. Now also let's verify the count as well, if it should be 0. Yeah, let's wait for it to become 0. So it has become 0. So all of the unsynced alerts are consumed. So like we restored the operations connection. So the uplink worker also like replace queued alerts and acknowledgements, mark them synchronized. So that's why the unsynced count returns to 0. So local detection remained active throughout this outage, right? So let me bring back terminal 5 to anomaly as none mode. So we have brought back the anomaly as none mode. Now let's see the benchmark results that we have. So like these are the benchmark results for M1, M2 and M3, like mean latency, P95 latency, model size KB, accuracy percentage, critical recall percentage, energy millijoules, CPU percentage normalized, TDP consumption. Right, so yeah, so these are the results you can see for all of the M1, M2 and M3. M2 being like having accuracy percentage and critical recall has the best one, like 100 and 100. Right, like next let me move to the so Pareto chart. Let me show you the Pareto chart. Mm. So we compare M1, M2 and M3 using mean latency, P95 latency, size, accuracy and estimated energy. M2 full int 8 is 3.38 kilobyte with 100% accuracy and 100% critical recall. M3 falls to 49.15% accuracy and 27.78% critical recall. We therefore like deploy the M2. So yeah, so final SLA acceptance must run on the Raspberry Pi actual one. Now let's move to the Ansible idempotency check. Yeah, so let me execute this command. So this is the name of the Ansible our deployment for the LogiEdge bridge. So like we have 7 tasks, so our playbook has like 7 tasks, so these are like the 2 consecutive runs without changes between them. So the second recap shows changed 0 and failed 0, proving like idempotent deployment without unnecessary restarts or transfer. So now let's pause this for like getting the genuine PSI back. So we need to see like the PSI should be recovering. We'll pause here and wait for the PSI to come back for less than 0.10. It should recover, right? Because the simulator has come back to none. So yeah, let me stop it here. So let's resume and let's see like the recovery. So PSI monitor terminal 4, if you see right here, like it peaked up to more than 0.25 and then it kept increasing, and then after we brought it back the anomaly to none, we see like the PSI has started dropping and right now like it is less than 0.1. So which is what is the recovery that we saw because we brought back the broker. Now let me quickly show you the hardware justifications that we have. So this is the hardware justification, like arithmetic intensity and roofline is noted here. So arithmetic intensity is 45 mfl of per divided by 18 MB is coming to 2.5 FLOPS per byte, right? So like we selected Raspberry Pi 5 with AI Hat Plus. Its estimated 7.5 watts meets the 10-watt limit and costs about 1/3 of Orin. Orin violates the power limits while STM32 still needs flash, SRAM rollback and deployment proof. So arithmetic intensity is 2.5 flops per byte. So the supplied ridge point is like 1.33. So like therefore the supplied roofline classifies the workload as compute bound, supporting the int8 SIMD and operator fusion. And like the OTA recommendation that we give is for a route diverse canary rollout to 10 trucks and then followed by the remaining 75 trucks. So canary limits safety exposure, full replacement risks the whole fleet. So while permanent shadow mode adds compute without controlling alerts. So approval also like requires signatures, pre-processing compatibility, latency and outbox checks. So so having said that, like on a high level, like this architecture like keeps sensing, pre-processing, like inference, alerting and durable storage inside the truck, right? So and also like we saw the mainly like PSI was recovering good, like starting when there was nothing, no issue, it was less than 0.1 and then again it got worse and went more than 0.25 and then again like it came back to less than 0.1. You can still see it is still recovering to less than 0.10. Let me check the Parrot chat once. Let me go here. So the Parrot chat supports like M2 full int 8 because it preserves like the accuracy and critical recall while reducing the size, latency and estimated energy. Right, so so we demonstrated like all 4 sensor models modes, local inference during a remote outage, durable queue growth and replay, PSI below 0.1, above 0.25 and below 0.1 again. So 3 model variants across 5 metrics. The Docker model cache boundary also we saw, and a 7 task deployment with changed 0 on the second run. Our final design like uses the Raspberry Pi 5 M2 full int 8, feature level fusion, offline store and forward alerts, PSI monitoring, idempotent Ansible deployment and Canary OTA. So this completes the LogiEdge demonstration for Group 20. So thank you so much.